Right, okay, so we're on session 11, which is the last session, learning session that we have in this course. So really, really well done. We're going to be looking at similar shapes in this session after we have done our recap, of course. So if you're working on the printed version, great. I'm going to keep it to this size, scroll through slowly, do the same with the answers. And yeah, just hit play when you're really ready, okay? Okay, so here's your answers. There we go. So hopefully that has gone well. We're going to be looking at similar shapes. To start off with, though, I'm going to ask you to describe this transformation. So hit pause and press play when you've done that. Okay, so hopefully you wrote that it was an enlargement by a scale factor of 2. There's no center for us to be able to identify because it's not on a coordinate grid, so we leave it there. And the reason for this being here is because that is exactly what similar shapes are. If you read a sentence in an exam that says these shapes are mathematically similar, that word similar is telling you they've been enlarged. There is a scale factor that connects the two shapes. And because of that, you are able to problem solve. So if I was to just draw, let me just draw, hopefully this will come out fairly well. That's an L shape, that's an L shape, and that's an L shape. These L shapes are mathematically similar. This one is not, because it's not scaled up properly, yeah? That has 1. If I got a scale factor of 2, it changes to 2, but it stayed as 1. Whereas this one has multiplied up. It just doesn't scale up. So they're not mathematically similar. So those are the differences. With mathematically similar shapes, the angles are preserved. So our angles, 90 degrees, are still 90 degrees. And that's true. If those angles had been 60, then the enlarged shape would be 60 as well. Angles are preserved. The edges are the things that scale, okay? So that is a definition, if you like, for similar shapes. Similar shapes are scaled versions of each other. They're basically enlargements of each other, okay? Now, if I was to keep this super, super simple, tell you that edge was 3, that was 2, and that was 4, and say, I want you to work out X, because of your current knowledge about enlargements, you would find that pretty straightforward. You would see that this is connected by timesing by 2, so you times that 3 by 2, and you would get that your X is equal to 6, really without too much effort whatsoever. With mathematically similar shapes, it's less likely that they're going to keep things that simple. It's more likely that they are going to put numbers on that aren't quite so easy to work with. So let's give you an example of that. Let's say let's keep that the same. Let's say that was 3 and 2, but I told you this was 3.8. You know, what do I times 2 by to get to 3.8? It's a completely different question, and I'm wanting to grab my calculator already. And for some students, they find it quite tricky to know what to do with those numbers in order to find the scale factor. So boxes and labels is a method that you can use here. Now, if you've done some of my other courses or if it's come up in some previous learning, boxes and labels is amazing. It fixes so many different areas of the GCSE so easily. It really is a great little tool to have up your sleeve. I'll go through it with some detail in case it's your first time of ever seeing it. You can use it, like I say, all over the place. one of the things that you can look for is if a question has got 3 pieces of information, which this one does, it's got a number on this edge, a number on this edge, and a number on this edge. We've got 3 numbers. So quite often, and not always, but quite often, if you've got 3 pieces of information, you can use boxes and labels, and it'll help you find the 4th. I label my columns S for small shape and B for big shape. And then from the diagram itself, I find the connecting pair. There's always a fact that goes together. So that 2 is the base of my L shape, and 3.8 is the base of my enlarged or my similar shape. So those 2 would go side by side because they are paired together. And that's really important. If you don't get the pairing right, then this doesn't work. The only other piece of information that I have is the 3 coming off of this edge. This edge matches this edge, which is perfect. That's going to help me find X. I've got to make sure, though, that I put the 3 in the small column because it's come from the small shape. So once I've got to that stage, I can then take the numbers and put them into a piece of maths, because at the moment they're just sitting in a grid, but the grid's organized them in a way that one of them has become trapped. Now the trapped number, oops, get my pen back. The trapped number is that one there. So what I mean by that is if you remember that tile game that you might have played when you were younger, where you kind of slide the tiles around to get the alphabet in order or something like that, you can only move a tile into that one space that's available. So if this was that game, the 3.8 could move into this space, or the 3 could move into this space, but the 2's not going anywhere. The 2 does not have a space to move into, so it is trapped. So that's what I mean by that. The trapped number always goes on the bottom of a fraction that I'm about to make. So it's always the denominator. So this trapped number is always divided by whatever that number is. The 2 remaining numbers, we are going to put 1 as the numerator and the other one as the multiplier. Does it matter which way round? Not at all. There is no rule. If you're doing it on a non-calculator paper, then you might want to put them in a way that makes the fraction, maybe it'll cancel. You know, you can manipulate it in a way if you have to. But if you're on a calculator in similar shapes, this type of question is pretty much always on the calculator, unless they're really straightforward numbers. So you just pop them in the calculator and away you go. So that goes into the calculator and we get 5.7. So this missing edge is 5.7. And that is similar shapes. Obviously, we can change the question. We can do our best to make it as difficult as we can. But ultimately, you cannot problem solve similar shapes unless, one, you've got a pair that can come off of each of the shapes. If you haven't got that you can't even get started. So that's always going to be there. You are going to have one other that will pair up to a missing edge. It all goes into the box. Hey, presto, you get your answer. Okay, that is how similar shapes work. So let's have a look at this question. Okay. It would be absolutely fantastic if you paused and had a go at that. Just play around with it, see how far you get. You may get all the way to the end and be super, super happy. You may get halfway through and then think, oh, I don't really know what I'm doing. As soon as you get to that stage, you just hit play and I'll talk you through this question. Okay. Okay, so the first thing to note is the use of the word similar. As soon as I read that, I know that they are just enlargements of each other. And hopefully I'll train my brain to go, read similar, boxes and labels, just straight into it. Okay, so I've got a big and a small shape. One of the things that they have done is they've kind of rotated, they've changed the orientation of one of them so that it's just a little bit harder to match up my side. So that's something they can try and do just to mess with you a little bit. we'll use our highlighters to match everything. So I have this here, A to B. Now, A to B is not matching with 10. If I just launch into it without thinking, then I'm going to make a mistake, because I can see that this diagonal line is coming off of this edge, and there's a right angle. So I've kind of got an acute and a right angle. Well, if I look at this, I've just got two right angles. So it's been rotated, and it's my E and F that actually matches it, where it's just did a quarter turn on us. Okay, so 6.3 and 18 is my matching pair. So into the box that goes. It says work out DB. Okay, so it wants me to find this edge here. So I've got to go to the edge that matches that one. Okay, so it's either the 10 or the 6, and I need to make sure that I choose the right one. So again, using a bit of color. If you don't have color, let's say you're in your GCSE and you don't have a highlighter, then you could say, okay, I've just matched that side with that side. So you've just marked it in a way that helps. And then the X is coming off of the same edge at a right angle. And that's the edge coming off the same edge at a right angle. The other one is coming off at a completely different angle. So on my big shape, I've got the 10. So 10 will go in there. Then I just set it up with the rules of this particular method. The trap number goes on the bottom, 6.3, and the 10. I could do it the other way around as well. It makes no difference. And then I put that in, I get 3.5. So 3.5 is dB. And we'll put in our centimeters. Then it says work out the length FG. All right, then let's locate FG. So FG is here. Go across to the smaller shape and mark that in, and I can spot a problem here. There's no number. I've got to have one out of the two if I'm going to be able to use this method over here. So I've got the pair because I can just use the same pair that I did before, but I do not have a third number to put down. Obviously, I don't have FG because that's what I'm supposed to find, but I don't have this either. So my method, where I've literally just said to you, if it's similar shapes, use your box and labels, it's going to work, suddenly has stopped working. So you have to think, right, well, this question is there. It must be solvable. And my similar shapes method isn't working. So something else is going on here. This is what it is. And I apologize now for anyone that thinks, oh, that was mean. If I just insert a line here, I split the shape into a rectangle and a triangle. Not only is it a triangle, but it's a triangle with a right angle. It's also a triangle that has an edge of 10 and an edge that I can work out because I've got 18 as the full length and 6, let me just show you what I mean. 18 is my full length, but 6 of it is there. Okay, and 18 takes 6 is 12. So I know that that is 12. So what have I got? I have actually got a right angle triangle with 12 and 10, and that is FG. That is what I need to find. Pythagoras has snuck in to this question, which is what Pythag does. It's very naughty. You've always got to watch out for it, okay? If your normal route is failing, something else has got to work, and it's a case of trying to almost be a detective and work out where the clues are and take it from there. So we are going to do a squared plus b squared equals c squared. We've got, there we go, we've got the 12 and the 10. So 12 squared plus 10 squared equals, I'll keep it as c squared. I could label it FG if I wanted to. There's no kind of big rule there. Put that straight in the calculator. You've got 244 and then square root. That is going to give you 15.62 to 2 decimal places. So the answer is 15.62 centimeters. You'd round to whatever you were being asked to in the question, of course. All right, so maybe I was a little bit mean doing that so soon into our examples, but similar doesn't change. It is literally put the pair in and then put the third piece of information in and boom, and that is it. The only time it's going to change is if they literally change the question on you, okay? All right, here is another example for us, okay? Now, if you don't want any hints whatsoever, you're going to hit pause now and have a go. If you want a hint, I'm going to give it to you now, and then you're going to hit pause and carry on, okay? So the hint is, whilst they've given us one diagram, and there is absolutely no mention of the word similar, there doesn't need to be, because actually it's like you've taken a big triangle and you've just dropped a smaller one inside it. And the fact that it shares these edges means that they will be similar, all right? So what you've got in this diagram is you've got a big and a small triangle kind of on top of each other. So the hint is separate them out. Separate them out so you can see them better and then go through the normal process. Now, that's all I'm telling you. Hit pause and press play when you're ready. Okay, so I'm going to draw my big triangle. It's got a 12, and that's all it's got, to be fair, because that 10 is E to D. So I've got my small triangle with a 10 here and an 8 here. So I can see I've got 3 pieces of information. I'm going to label it big and small because I've drawn it that way round. And it doesn't matter as long as the numbers are going in. So my matching pair is the vertical side there. So I've got 12 and 8 and then 10 for the small. I'm going to divide by 8. So put the other 2 any which way around you like, it doesn't matter. That's going to give me 15. So I'm going to put it on my diagram. All right, I know that this entire length is 15, but the question is asking me to work out AE, just that bit there. So to finish it off, I'm going to do 15, take away the 10, and that is going to give me 5. So AE is 5 centimeters. Okay, and like I say, they do not need to use the word similar because of the fact that they're like superimposed onto one another. It means that they have to share the same angle sizes, so they must be enlargements of each other. And that's it. I'm not going to do any more. I've got the worksheet for you to practice. Again, I'll do this as a large version for anyone wanting to work from the screen. Otherwise, you can work from the printed version. And I'll slowly go through the answers as well. And then that is it. You have actually finished all the learning for the course. We'll obviously have our final consolidation. It normally goes over a couple of videos so that the videos don't get too large. But we're going to literally cover everything, look at a whole load of past exam questions, and then model how to answer them. So you're going to be ready to smash it, hopefully. All right, well done today. I'm going to disappear and I will see you next session. And the answers.